Alright, today we're going to talk about probability. So probability is how we predict an outcome. An outcome. So to do that, to predict that outcome, you need to know the number of successful over the number of total events. Alright, we're always talking about events. Okay. Now, when I write this, there are two types of probability. There's theoretical probability, which that's what we're going to start off with. That's what should happen, right? We have not done this yet. We're going to predict what's going to happen. Experimental probability is a little bit different. That's after the fact. All right. Now, whenever we talk about probability, it's either always going to be a reduced fraction, or it's going to be a percentage. Because all probability is going to be between 0 and 1. Alright? If it's guaranteed to happen, then it'd be 1. If it's impossible to happen, then it'd be 0. Alright? But so you can't have like a probability more than 1 or 200%. That's not possible. Alright, so a die is rolled. So the reason we need to know about a die is because that's going to tell us our total. Alright, our total options. That goes on the bottom. So it's always going to be on the bottom. So total. Is there going to be 6. Now, what numbers are less than 2? So the successful numbers that are less than 2 is going to be 1. So that's it. So my probability of less than 2 is going to be 1/6. Now, a lot of times we don't write it as 1/6. You'll see as a percentage, which is 16.7%, or 16 2/3%. B, 1 or 2. So my successes are 1 or 2. That's 2 different numbers. So my successes is going to be 2. My total, it's still a die, is going to be 6. So my probability of 1 or 2 is going to be 2/6, which is 1/3. Remember, you have to reduce the fraction, or it's going to be 33.33%. All right, that's it. All right, the next one: a jar contains 65 pennies, 27 nickels, 30 dimes, 18 quarters. A coin is randomly selected from the jar. So, the first thing you have to do is you have to know the total. The total is going to be 65 plus 27, which is 92, plus 30, which is 122, plus 18, which is 140. So that's my total. So I already know that both out of these are going to be over 140. Right? Now, the probability of a nickel or a dime, all I'm going to do is say it could be a nickel, which is 27, or it could be a dime. There's 30 of those. So I'm going to add those two together and then put them over 140. So my probability of a nickel or a dime is going to be 57 all over 140. Now 57 over 140 probably doesn't mean a bunch to you. So we need to write it as, I must have the original fraction. I got that. The reduced fraction, which I'm not going to reduce it. I'm actually going to write that as a percentage. So about 40.7%. Alright, so of not a dime, okay? So the not a dime would be the same thing as having all the pennies, the nickels, and the quarters together. Or I'm just going to take not a dime, I'm going to take all of them, which is 140. I'm going to minus the dimes. So I'm going to have 110 over 140. So my reduced fraction, so my probability of not a dime is going to be 11 over 14, or, that's the reduced fraction, or I'm going to write it as a percent. I think most of you guys will like percentages better because that just seems to make more sense to you in your brain. So you're going to put 11 divided by 114 times it by 100. You're going to get 78.6%. So that's it for that one. Alright, last one. The table shows the result of an experiment. That tells me right away this is going to be experimental probability. Find the experimental probability of rolling a 3. How does it compare to theoretical probability? Well, I have to find the 3. There is 8 threes. So my success over my total. So the probability of 3 is my success. I have 8 threes over my total. Well, I have 10, 20, 30. So 8 out of 30. Now, so the probability of a 3 is going to be equal to 4 over 15. If you want to just write as a reduced fraction. Or you could take the reduced fraction and write it as a percentage. So 4 divided by 15 and times it by 100. I'm going to get 26.66 or 26.7%. Alright, that's the experimental probability. Now, the theoretical probability is what should happen. Well, if a fair die is rolled, they all have an equal opportunity. So just to get the theoretical probability of a 3 is 1 over 6, which is 16.7%. So now I finish it up. All right. How does it compare? So this is experimental. This is theoretical. How does it compare? In this experiment, three overperformed by 10%. All right. So 3 did better than we expected by 10%. All right. So that's significant in terms of rolling die. All right, and that's it for this one. That's it for this Firestarter.